We are going to look at two examples of finding domain and range of functions using algebraic inspection. In the first example, we see we have a function f(x) equals square root of x. Now, when we think about it, what kind of values of x can I actually substitute here in this function? Will it be possible to have a negative value for x? Let's say, as an example, if I have a value of x which is -3, and if I try to find the square root of -3, then that is an error. There is no real answer for this value. So this is actually quite clear when you think about it. When I have a positive number and I square it, so multiply it by itself, I will have a positive result. On the other hand, if I have a negative value and I square it, then I will also have a positive result. So square rooting positive number is okay. However, if I enter a negative value there is never going to be any answer for that. So in this case, then it's clear x cannot have a negative value. So what is the minimum value possible? How about 0? Will it be possible to find square root of 0? In this case, yes, because we have a value, a number, 0 itself, that when I square it, I will have 0 as an answer. So in this case, then we know that the x value that I can substitute for this function is anything greater than or equal to 0, not less than that. So if you want to check it, let's say, and put here in your calculator a function square root of x, then this is what it looks like. So then your domain, the x value, starts from 0 and greater, not less than that. Similarly, then the result will also be minimum 0 and above that, not less than 0. So then in this case, the range is y value which is greater than or equal to 0. Second example, we look at this function y equals x squared plus 3x plus 4. And knowing that this is a quadratic function, then we know that the result or the graph will be a parabola. And because the value of the coefficient here of x squared is 1, which is a positive value, then we know it's going to be a parabola which is facing up. So because there is no requirement of x value for a parabola, it goes on forever left and right, then the domain of it is going to be any real number. So there is no restriction on the x value. We can have any number for x, and therefore the domain of this function is any real number. Now, when we think about it, the range is going to be above a certain value. We don't know yet what that is, but then we know that minimum y value is going to be where the vertex is. So whatever number of the y coordinates of that vertex will give us the minimum value of the range. So your range will be anything above that and itself. So let's check, how are we going to find the y value of this vertex? Remember, vertex happens or is located at, of course, the axis of symmetry. And we do have a formula for finding the axis of symmetry of a parabola. X value or x coordinates or the equation of the axis of symmetry is x equals minus b over 2a. So if we check our formula, our equation, then b is positive 3 and a is positive 1. So then in this case, you will have a negative 3 over 2 times 1, which will give you -1.5 or -3/2. However, this is still our x coordinates, x value of the vertex. How are we going to find the y value, the y coordinates of the vertex? Then we just need to substitute the x value into the function formula or equation. So then we will have negative 3 over 2 squared plus 3 times negative 3 over 2 plus 4. So in this case, I will have positive 9 over 4 minus 9 over 2 plus 4. So if we see here, applying what we know about fraction subtraction, then we can write 9 over 2 as 18 over 4, and then we will have negative 9 over 4 plus 4, which we can write as 16 over 4. So in the end we will have 7 over 4, which we can write as 1 3/4. So we know that, okay, the x coordinates is negative 3 over 2 and the y coordinates of our vertex is 1 3/4 or 1.75 if you prefer. Then we know that the range of this function is anything above or equal to 1 3/4 or 1.75 if you prefer.